All right, great. So we're going to do a midterm review today. It's going to be very similar to exactly what the study guide is. Nothing too different. I'll talk about constructors and deconstructors for a little bit, and then I'll talk about the linked list data structure more, and then we'll talk about these three algorithms, the insert, delete, and search. And nothing new that you haven't seen already, either through class code or the homeworks you've already done. This is literally your time to learn. Ask all of the questions that you have, and I think it's the best idea to just be greedy and just, if you have any doubt in your head, just speak it out, vocalize it so that you could like learn it right now, because that's what SI is for. You should also try really hard to actually engage and complete the problems that I give you, because the point is to just get you up and going. What you need to study is every single piece of code that Dr. Erickson did in class. You need to know exactly what the code is doing, right? So if you go on Blackboard, you will see that he has these GitHub links on under the assignments tab. You should go to them, and what he does is that he does the live coding in class. Like, you see it, and then he provides it to you later on for you to study off of. You should be able to exactly like know, why is this function doing it in this way? What is that algorithm doing, right? Another thing you should be doing is your homework assignments. He gives very challenging homework assignments, because in turn your studying for the test will be much easier. And you will see that the test is not going to be something like out of the blue. If you have done well with the homework, meaning that if you actually understand what the homework is asking you, then you will do fine. Another thing that you have is the class textbook. You could read it, but like just for conceptual things, for like theoretical help, if you need it, you should do that. Otherwise, for code-wise, their style of coding, Dale, whoever is the author, their style of coding is a little bit like different than the modern times. So you should just rely on the GitHub repos that you have. So everything I'm going to say is going to be predicated upon this fact that you are in this class because you are learning how to build things. Like literally, you should be thinking of you having a bunch of wood, and then as you're writing your code, you're building a house. And with that house, when someone builds a house, you don't expect it. You expect specific things from a house, right? You would want it to have windows. You would want it to have doors. You would want, if there is a chimney, you would want the smoke to go out without like causing a fire or killing the residents. You need to have the same type of thinking about these data structures, right? So you should know how to create a constructor, because it's kind of like the setting up of everything. Just like how a house needs a door, and if the door is a little bit above the ground, you need the stairs, right? People need to insert things into the data structure. Therefore, you should provide that, right? And you should let people search your data structure. It's the contains algorithm, right? You should allow people to delete something out of the data structure too, right? You should have an algorithm for is empty, because usually people want to know if this algorithm, if a data structure is empty or not. And also it is a really good helper function for yourself, right? And also you need to have a deconstructor, because imagine someone builds a house and then they don't clean up the area outside of it, right? It's just still got like a bunch of like dirt and bags and random things. That doesn't look so residential, right? Same thing applies to the memory of your computer. You need to clean up so that after you're done running your program, your RAM is still not being in use. So the data structures you've made so far, I want you to also think of it like this, right? You've made two data structures so far. You have made the image maker, which looks like this, and you have made a data structure called chunk list, which looks like this. Visualizing things is very important in this for data structures in any case. Even when you're doing interviews, it's really important to display that, to demonstrate that you have a clear idea of exactly what's happening, right? So this is what both of them look like. So if I were to ask you, what is the underlying implementation for each of these data structures, what would you answer? Class, yeah, they are a class. But how did you implement that class? What is the underlying implementation that the code for that implementation is written in the class?
You mean like arrays and linked list?
Right. So what is the underlying implementation for, let's say, the image maker data structure?
A three-dimensional array?
Exactly. And what about for the chunk list?
Linked list.
Linked list.
Exactly, a linked list. So it's the underlying implementation of everything in this class will come down to either it's an array, you either implement it using an array, or you will implement it using a linked list, right? Which is why if you want to study anything, you should really, it just comes down to doing linked lists. And guess what? The assignment you just did, it had both of these components. So he's really like just really like paved the way for a very easy start to everything. Your chunk list has nodes and each node contains arrays. So what better thing than that? If you want to study like stacks and queues, circular linked list, double linked list, all that stuff, you could still, those are just things that are implemented using these two data structures, right? So it should not stress you out that much if you want to create a stack. Because you know how to create a linked list, you're already good to go. So let me switch tabs. We're just going to read the questions for now. So these classes, I have 3 of them, and I want you to code the default constructor of each of them. So there's a class called shape, a class called contact, and a class called vector. So write the default constructor for these classes. You can do it either in CLion or on Replit or on a piece of paper. We'll take like 5 minutes for you to do this. If you guys are done with the first one, you could drop it in the chat so I can look at it while we have a couple of minutes left. Anybody else has anything completed? So from David, we have double width and double height. He wrote double width is equal to 0, and then double height is equal to 0. Whereas Karina, she wrote width is equal to 0, height is equal to 0. Which one of them is correct? This one is correct, because you don't need to say the data type of anything anymore. And it's already declared here. So there's that. So I will remove this. We just remove the height, right? Okay, so she has name is equal to null pointer, and then phone is equal to null pointer. Fantastic. That's exactly what I wanted. Notice how you don't need to know exactly what is this shape. You don't need to know the premise of why did somebody make this contact thing, right? You don't need like a 5-page PDF write-up the way that what Dr. Erickson is giving you for like chunk lists. We know what's the data type and the names of the private member variables, which is these guys. I'll set them to whatever is a good default value. And then for vector, what do we have? Array is a pointer to an int. She set it to null pointer. That's great. And then we have int, max capacity. A great default starting number for a value for anything that's int is 0. Same thing that we saw with double. You just set it to 0. And then current size is also an integer, so we just set it to 0. These are fantastic. Great. Any questions about this? This is, you know, the same thing you've been doing basically for your assignments, except Dr. Erickson gives you the full .h file where you know exactly what's happening. But here we're just like stripping everything down and saying that nothing matters, basically, like, you know, like knowledge wise, nothing matters other than what's the name of these private member variables and what is the data type of them. And if it's a number, put it to 0. If it's a pointer, put it to null pointer. If it's a string, put it to the empty string, right? Just, or maybe a space, something, anything, right? Anything that makes sense, basically. And right now, what makes sense is just putting 0 across the board. So second question is, which of these classes needs a deconstructor?
Is it just the classes with the pointers in them?
I wouldn't be too comfortable saying just the classes with a pointer in them, just because what if it's you don't really know, because this name, it's a pointer to a character. Then maybe they decide to make a full-on like a huge array out of it, an array that holds characters, or maybe it's just going to hold the letter A, right? So maybe the one that you would like intuitively say is this one, because this is the one that you for sure know they're going to make an array out of it, and the size of it could go to 1,000,000, and you would want to wipe that off of your memory. But it totally makes sense to be like whatever that has a pointer. Or a better way of saying that, whatever that makes things dynamically, right? During the runtime, whatever that creates things uses memory during runtime, we want a deconstructor for that. Make sense to everyone? Because my follow-up question is, out of the 2 homework assignments that you guys did, which one of them needs a deconstructor?
The chunk list.
Yes, the chunk list. And you didn't even have to make a deconstructor for this image maker thing, right? Why? Because it was just an array that you knew the size of. So it was pretty easy. Cool. So, okay, so here's just some questions. So a member function that is never declared with a return data type, but may have arguments, which of these options? Constructor, deconstructor, both of them, or neither of them? So a member function that is never declared with a return data type, but maybe it has arguments. Okay, we have answers for constructor. That is correct, the constructor. It may have arguments, it may not. So a member function that is never declared with a return type and can never have any arguments. Which one is that? Karina says deconstructor, which is actually true. You will never write a deconstructor with values going inside of it. Make sense? 5th question. So there's a class in main.cpp, and I want you to make it into a template class, right? So here's this class, this guy. So make this into a templated class. Do we have an answer yet? Okay, perfect. Yeah. So what we're getting is that we just put this guy on top of the class, and then you change all the ints to t. I agree with that. So this was previously an int. Does that make sense to everyone? This is, again, you don't need to know like anything other than just syntax here. Yes. Yeah.
You don't have to do anything to the constructor?
So this constructor, no, but this one, you're gonna have to change this one to a t as well. And then this guy's data type is not int, it's a t. So you do that. Let's say I run this code and the data type here, and instead of being t is, I just still gonna keep it as integer. But my question is, given that this is an integer type of thing, what is this gonna print out? What is going to be the output of this? Interesting. So your thing is 1020 0. That's okay. So this is a really silly example maybe, but this is a really great time to just draw it. So yeah, David says that I thought it would be 50. I kind of agree with that. So before we even run it or execute anything, right? So we know that we have something called a tank, right? And I will like draw it using this shape for whatever reason. This is the shape of the tank, right? And so I have a storage 3. So what does the storage thing look like? We know that it's an array. Basically, we know that. But what can it hold? And instead of integers, it can only accept tank type. And so what this does is that it creates supposed to create 3 objects. This line number 18 sets up the storage like this, creates 3 objects of this guy. There's 3 of them now. They go like this in here. And this array cannot hold integers, it cannot hold strings, characters, it only can hold the tank data type, okay? So the first one, what is going to be the value of it? I agree that it is 10, but only because, so my question would be, you know that it is 10, but then, like the deeper question is like, which constructor did this value 10 call? The second one, yeah. So because we have the number, right? So this guy has a 10. I can just move 10 here. Here's 10. Second one is, again, number 20 calls the second constructors. That's why you have a 20 here. Makes sense. But then what about for the third one? Why would the third one, why would we think that the third one would be like a 0.
It's because we never set a value for it.
Right, so in this class tank, when you don't set a value for it, which constructor is it going to call?
The default one.
Yeah, and so what happens in the default one?
We set it to 50.
Yeah, so then this guy becomes 50 here. See that? So we got the 10, 20, 50, right? And so you go and access the values that are within storage index, whatever that number is, 0, 1, 2. And then because you have an object that lives there, then you call its method the dot get gallons. And that's what this guy returns to you. That's where you get the 10, 20, 50. That was question 4 and 5. I kind of like skipped over 4 and went to 5, but anyway. So now the next question is initialize an object using a class called circular linked list. So what I'm saying is that in class, Dr. Erickson, he would give you a whole .h file and a whole like 5-page write-up of like exactly what the class is. I just give you a little tiny thing of like, this is what the class is. But now I'm even going to like take this away. I'm going to say just the name of it. Just the name is called circular linked list. Don't worry about what are the methods and what are the private members. Just initialize an object out of this class. Anyone has an answer for this question? Okay, cool. We got one answer. So what if I told you that this circular linked list thing, it's templated? How would this, what would you say then? So this is just the regular, I want the templated one. Let's say circular linked list, whatever it is, it's templated. How do you create something out of it? Still uncomfortable with doing templates myself. Okay. Well, this is the time we all get comfortable with templates. So what I'm saying is that, let's say we have something called class circular linked list, and it's like living in its own, wherever it is, in some file somewhere, right? And then it has this in it. It has this on top of it, right? And you saw how it would like change whatever is the private member variables. How do you make an object out of this class now? It's fine if you don't know, but you have to let me know that you don't know. Otherwise, I would think you're thinking. Not sure. Okay. So it would be the same thing as we have up here, this guy, except you have to tell the compiler what it is, what data type you want to use using this syntax. Let's say it's int. Let's say, I don't know, it's char, whatever you want it to be. So this is the same as if we went down here and I said that this is, again, templated. We've got template here. So here, now this is throwing an error. It's saying this is a template class. I don't know what to do about this, right? So I would just say this is an integer like this, and it would go back to being normal. Follow-up question is, if you wanted to create dynamically create something, right? You don't want to statically create an object. You want to dynamically create an object. What would you write then? So like in a linked list, it's not the user creates items and adds it onto the list as the program is running, right? They just use like insert, like just call that function time after time. You don't have an idea of exactly how big this thing is going to be, right? That's why you're always using that new operator. So that is dynamically creating stuff. That's using heap memory. So I'm asking you to create something, to create the object like that. Okay, so we use new. Cool. Yeah, new is definitely part of it. New is going to be in there, but also like, how are you going to initialize the object itself? So, okay, let me ask it this way. Like, let's say you guys want to create a node. How do you create a node? What were you coding for your assignment? Ah, great. So now, can you do this exact same line of code, but instead of the class name being node, the class name is circular linked list. So it's funny that you would know like this just new node equals new node. You know this instantly, right? So this is how you dynamically. Dave's like, I can only do node. No, so node is some object. It's something out there too, right? But now instead of this name, we have, I'm telling you, the name of the class is circular linked list, and just call it like new object or something. And how would this change? Well, you would be calling the constructor of your class, What is the name of the class? It's this. Do you have any questions about this? Because I feel like this should be like really, should come easy to you.
So to create something dynamically, you have to do the pointer thing.
Yeah. Yeah.
Why is that?
Because you need to create something and it's on the fly. You would be using heap memory and you don't know exactly what part of the memory it's going to be, but it will be an address. In general, it will be an address of this object you just created. That's why you just create a pointer and you say like, whatever that address is, I'm just going to put that address here.
Okay.
Yeah, because the data type of a circular linked list and a pointer to a circular linked list, these are two different data types. This guy holds an address. This one holds an object. So this one is the abstract data type you just created. Maybe I should just say that, abstract data type. ADT. Okay, so then this one should be kind of easy. So initialize an object using this class. This is your class, make an object out of it.
We're making a templated one?
Yeah, so the class is templated. It's got template. Okay, I have an answer. Cool, cool. Anybody else has an answer they would like to share? So if we were to, get into the habit of drawing things so that you are very comfortable with it, right now, what the object you just created is, what does it look like? If we were to like draw it. Here we go. We don't need these methods down here. So you have this thing called SV, right? And I'm just gonna draw this square thing to show that this is the object. What is inside this box? What is it? What is the state of SV right now?
Empty.
Yeah, well, it's not empty, right? Because it has it has at least 2 private member variables. So there's things inside of it. You can just, divide it in 2 actually. Here we go. What's inside of here? Okay, we got 0 and 0. Sorry, I didn't see the chat. We got a 0 here and we've got a 0 here. Perfect. This one line of code calls the constructor and the constructor sets up these values for it. Now, if the user wants to go on and use maybe, I don't know, some other, they want to use all these other methods that's available to them, then they can. Do you have any questions in general about like what we just did? It's really just like it's got a game component to it because you just gotta like, be like, what if I do this? What if I do that? Take the next 10 or 15 minutes to create a class for a node and then create a class for a linked list and then implement the delete algorithm. Because if you get delete, then you have checked off all of the other things for other algorithms. So I will make, like something like this, like a linked list.cpp. I want you to just go here and create a linked list. Create the node that you would need. And then implement delete algorithm. Okay. Oh, and this is just like a regular linked list, right? It's just your node should have only 2 things, like a value and then next. We're out of the chunk list world now. Just something very simple.
Fatima, I have a question. If we are writing the whole code in a single file, then just how we are used to doing the class that we have a .h file and after that we link it to the CPP file. But here we have just one CPP file. So where should we implement the function? Like in the class itself?
Yeah, you can do it in the class itself if you want, or you could, so if you have a class, is there something linked? Let's call it this, right? You can come down here and you can say linked list name of function.
Okay.
Like
okay,
that.
got it.
Yeah.
Yeah.
Does anyone want to share their private member variables?
So do you just have a struct with the node next and like, for example, int?
Okay. Okay.
Then we could do like a node head and node tail.
Yeah, fantastic. And I think we're all at a point where we know that the struct is just, what is the constructor going to do? Just real quick.
Set int to 0 and
Send who to 0?
set the val. Set val to 0 and node next to node pointer.
The constructor?
Or yeah. Or the head to null pointer.
Head to null pointer. Whatever that's inside of this node, we haven't created it yet, right? So whenever we create, then we worry about like what that is. So the class itself, it has only two things that belongs to it, the head and then the tail, which is why in this picture you see this is the list, these are your chunks. Without the chunks, if you take those away, you really just have three variables, and it's the head, tail, and the list length. So the linked list is the orchestrator of all the nodes that you will eventually, or the user will eventually create. But the list itself is just its own private member variables. So we've got a constructor, right? That's cool. Real quick, what's the deconstructor going to do?
It's just going to go through each of the nodes and just deallocate the memory.
Yes, exactly. So what's the code for this?
Could you do like node temp
Okay.
or temp?
Mm-hmm.
And then you could do temp equals head.
Uh-huh.
Head equals head next. And then delete temp, maybe throw it all in the while loop.
Right. This all should go into the while loop. Delete temp. This all should go into the while loop. So just checking in with Karina's thing. So why would we just have empty brackets? It's going to, you need a deconstructor for this class, right? It's a linked list. We know it's going to like grow. Whatever that the user creates, we want to wipe it off. You definitely want to have a deconstructor. So we got a while loop here. What's in the while loop? What is the question of the, what's the condition of the while loop?
While head does not equal null pointer.
Everybody, is this like kind of like second nature to you at this point, or we good?
No, I still have to think hard about it.
Oh my God. This, like setting up a constructor and deconstructor, it should be, I think it's enough to know that you need a while loop that walks through, deletes people. Like that's a good way to think about it. Basically, the way that you study for this whole thing is just this. You just get to like play a game with yourself and just use your imagination, right? So like in the picture that I drew, what it would be, what would happen if I wanted to delete the beginning, the end, the middle? What if my list is empty? And then you can do that same thing, for I don't know, insert, append, prepend, basically like everything you've done for the chunk list, but just for something specifically that's a linked list, not like, you don't have to worry about like iterating over an array or anything like that. And that's basically how you study for this. I wouldn't worry about it at all, like it will not like ask anything to be kind of like, haha, gotcha. It's just really just to make sure that it's an extension of you did the homework and now you're just here to also display that you know what the homework was about. So for example, when I tell you guys like dynamically create an object, you know that you were doing that for node, but then you should also know that that's dynamically creating an object. That's not just creating a node. You know what I mean? And then tomorrow there will be a session as well, something similar to this, but it'll be like longer. So I will do more like linked list and maybe like a little bit of like double linked list stuff. But yeah, that's all I had. If you don't have any questions, that's it. Thank you.